in this case, I'll go ahead and work this one out for you. We have the balanced chemical reaction there, the butane burning in oxygen to give carbon dioxide and water. And the question here is how many grams of butane are required to react completely with 47.2 grams of oxygen? So again, we've got a certain amount of oxygen, and we want to know how much butane will react with that certain amount of oxygen, but it's not the number of moles this time, it's the number of grams. So you just start the way you always start with these types of conversion or dimensional analysis type problems. You start with what's given, and in this case it's 47.2 grams of oxygen, and what's wanted is how many grams of butane are required to react with that particular amount of oxygen. So in this case, the conversion path is going to be from grams, what you're starting with, which is grams of oxygen, and we need to figure out a way to get to grams of butane, and the only conversion factor we have between different species, in this case oxygen and butane, is their relationship within the balanced chemical reaction, and that relationship is a mole-mole relationship. It's not a mass-mass, it's a mole-mole relationship, so we have to first convert to moles so we can get across the chemical equation and convert to a different species. So the first thing you're going to have to do is go to moles of oxygen. Once you're in units of moles of oxygen, then you can convert to moles of butane, and then once you're in units of moles of butane, you can convert to grams of butane, which is what is wanted. So the conversion factors you're going to need to do those conversion steps, first of all, how do you get from grams of oxygen to moles of oxygen? In that case, you're going to use the molar mass of oxygen. That's the relationship, because the pure substance oxygen always has 2 atoms of oxygen and 1 molecule of oxygen. The molar mass is fixed, and that's your relationship between grams and moles. So for oxygen, you just look on the periodic table. 1 oxygen atom is 16, so the molar mass, of course, is 32 grams of oxygen per 1 mole of oxygen, so that serves as a conversion factor. And then the moles of oxygen to moles of butane, of course you have the balanced chemical reaction, and it's 2 moles of butane, to use your reaction. That's shorthand for reaction. For the conversion factor from moles of one species to moles of the other, and that's going to be, in this case, 2 moles of butane are consumed for every 13 moles of oxygen consumed. And then we want to get back to grams of butane, so you're going to use the molar mass of butane to get back, and you just have to add that up. 4 times 12 plus 10 times 1 is equal to 58 grams of butane per every 1 mole of butane. That's the molar mass of butane. Okay, so now you just start your problem. You have all your conversion factors. Start with what's given, which is 47.2 grams of oxygen, and in this case you need to convert to moles of oxygen, and the molar mass, as by convention, is always written 13 grams of oxygen per mole, but this is an equality. Let me point this out up here. What it means is that this 13 grams of oxygen always equals 1 mole of oxygen. So I can write it as 13 grams per 1 mole, or 32 grams per 1 mole, or I can divide both sides by the 32 grams and write it as 1 mole per 32 grams. Either way is fine. And in this case, we're going to choose this version rather than this version because we want to cancel our gram as oxygen, and we're converting 2 moles of oxygen, so we're just going to write it as the inverse, which is also true because it's an equality. 32 grams of oxygen. So your grams of oxygen unit will cancel. You're now in units of moles of oxygen. We're here on a reaction path. We went from grams to moles of oxygen. Now we want to go from moles of oxygen to moles of butane. So there's 2 moles of butane reacted for every 13 moles of oxygen reacted. So the moles of oxygen cancels. You're now in units of moles of butane. You're right here on your conversion path. Now you just need to get to grams of butane, and the molar mass, the gram units on top as conventionally written, which is fine in this case because we want to convert to grams of butane per every 1 mole of butane by definition, and so that is going to cancel those, and then we're left with the amount of butane that's needed to burn that much oxygen is 13.2 grams of butane. That's the answer that you should have gotten if you worked it on your own. If you didn't know how to work it, now you do, and you should do some practice problems. Okay, that is a typical gram to gram conversion type problem.